So in this video, we're going to look at Chapter 1, Section 1, and then Example 1, Understand Domain and Range. So we're asked in question A, what are the domain and range of the function defined by y equals x squared minus 3? So we're looking for domain and range. We want to note this equation y equals x squared minus 3. Now, the graph we have here should be arrows because this graph is going to continue forever. This graph is going to represent y equals x squared minus 3. So first thing we want to look at is the domain. All right, I want to talk about what domain is. And in this section, it's going to be a lot of terminology, a little less calculating and a lot more vocabulary. All right, what the words mean and what we're going to do with them. So that your domain is the set of all possible inputs. All right, and in this case, we're going to think x values. So what numbers can we plug in for x? All right, in this problem, we have, again, y equals x squared minus 3. And we want to ask ourselves, what are we doing to x, and what are we allowed to put in as x? Well, x is being squared. All right, you can square any number. All right, any number I want to think of, I can plug in there and I can square it. And what you'll notice, our x-axis going left to right here, my graph is going to keep going right, the red line, and my graph is going to keep going left, the left line. So my domain, I know that x can be any real number. Now, what about range? All right, my range is the set of all possible outputs. So before domain was inputs and our range is outputs. And we want to think y values for this one. So going back to my equation, y equals x squared minus 3. I want to figure out what type of numbers am I going to get for y. Now, no matter what I do to x squared, so x squared, any number squared is always going to be greater than or equal to 0. So this x squared is 0. All right. And in this case, we're actually talking about a minimum. So y is going to be equal to 0 minus 3. So y would be equal to negative 3 in this case. Now, this, again, is the minimum value for my y value. All right. If I look at the graph, well, that makes sense. My graph goes down to negative 3, which is my minimum. And now what about in terms of maximum? Well, x squared, x we said can be any number. So that number can just keep getting bigger and bigger and bigger and bigger, eventually reaching infinity. And if I look at my graph, my y is going to just keep going up. Right? So there really isn't a maximum. Or if we want to say our maximum, let me change that color. Our maximum would be infinity. All right, positive infinity is just going to keep going up. So now that we've talked about what the domain is and what numbers are in our domain for this problem and what the range is, and again, what numbers are in the range, we want to write this in some kind of form. The first form we're going to look at is called set builder notation. So the textbook definition for set builder notation is that it uses a verbal description, It uses a verbal description or an inequality to describe, write the wrong words here, the numbers. Okay, the numbers in our set. So what does that mean? All right, that's a fancy way of saying it. Set builder notation, you open, so let's look at domain first. You open with a bracket, and then we're going to say that x, and then put one of those bars that kind of looks like the absolute value bars, and then we want to describe our set. All right, going back to domain, what do we know about the x? We know that x can be any real number. So that's what we're going to say, that x is a real number. And if we were to say this out loud, all right, so if we were to read it, you would say the set of all x such that x is a real number. Now again, this section is a lot of vocabulary, a lot of terminology. Now my range won't apply that same idea, the same set builder notation. My range in this case is going to be y this time with that same absolute value bar. Now remember, we were allowed to use verbal descriptions, which is there, x is a real number, or we can use inequalities. Well, what do we know about y? We know that the lowest number that y can be is -3. So we know that y is greater than or equal to -3. And to read this, we would say the set of y such that y is greater than or equal to 3. So that's our first notation or kind of option. The second one, and you'll see this far more often, I'll use this more often in class, is interval notation. It's a simpler method. It's a little bit less tricky. Really, interval notation, it's just a set of numbers, all right? It represents your set of numbers by creating a pair. They kind of look like an ordered pair. Interval notation is written in the form minimum, comma, maximum. Like you might see in XY. With parentheses, you may also see brackets. And you may see a combination of them. All right, it might be bracket, then parenthesis, or parenthesis and then bracket. But the main idea is that the minimum goes on the left, the maximum goes on the right. Now, these are not, like, this isn't X and Y. It's the minimum and it's the maximum. So let's start with domain. And we want to write this as minimum, maximum. Now, our domain is our X values. Our X values can be any real number. So what's the lowest number that we can think of? Well, that would be -infinity. And what's the largest number that we're allowed to have? Again, if we can use any of them, that's positive infinity. If you are using infinity symbols, you are always going to use parentheses. And I'll get to that in a little more detail in the chart below. So my domain is -infinity to infinity. My range, well, again, I want to start with my minimum. If we go up to the previous problem, or our previous work, we said that our minimum was -3, which is also shown in our graph. So my minimum is -3. My maximum, well, that was infinity. My graph kept going up forever. So my maximum was infinity. Now again, anytime you have an infinity symbol, it's always going to be a parenthesis. The numbers are a little bit trickier. All right, we have to decide, do we use a parenthesis or a bracket? In this problem, is it possible for the range to be -3? Can y be -3? Well, yes, it can be -3. Since it can be equal to that number, you're going to use a bracket. All right, so -3 is the boundary, but it also is a number that we're allowed to use. All right, you can kind of liken it to, remember when you would do like number lines? And you'd have an open or a closed circle. It's the same idea. All right, so if you had that open circle where it can go to it but doesn't actually touch it, that's your parenthesis. If it goes to that number and actually touches it, that's where you're going to have a bracket. Right. So parenthesis and bracket is kind of the interval notation version of your open and closed circles. Now, this chart is just going to summarize interval notation and set notation for us, or set builder notation. My interval notation is on the left, and then my set builder notation is on the right. And then the words that we would use to describe it would be in the middle. So I want you to take a look at this interval notation, this 3 and 4 with brackets. You'll notice that all real numbers that are greater than or equal to 3, that's why we've got a bracket. And less than or equal to 4 is why that bracket is there. Now, in the next example, this 3 here has a parenthesis. That means that it's just greater than 3. All right, it's not actually equal to it. But if I keep going, the 4 has a bracket, and that tells me it is less than or equal to 4. So it is possible to have a combination of parentheses and brackets. The next example, you have the bracket first and then the parenthesis. So that tells me it can be equal to 3 or less than 4. Your set notation, a lot of times you'll see those inequalities written there. It's kind of the same thing. It's just not used as frequently. You'll probably see interval notation a lot more. Take a look at these last 3 down here. Those are the ones involving with infinity symbols, positive and negative infinity. And again, notice if it has an infinity symbol, there's always parentheses with the infinity symbols. The other one, the number that it goes with, in this case 3, it depends on whether it's equal to or not. So it could be a bracket, it could be a parenthesis. And that's all for there. Part B we'll get to in another video.